In the last class, I was discussing this AGP series, but I think that we should discuss it more because actually this AGP, this infinite AGP we use many times in generative function. Infinite AGP series we are going to use many times. Okay, so that is the reason. Let's discuss this AGP series a little bit more. So what is this AGP series? This is basically, it means there is a arithmetic progression, there is a geometric progression, there is a AP, there is a GP, and this is the multiplication of AP and GP terms. So what this means, it's like this. So you have AP like A comma A plus D comma A plus 2D. Okay, so like A plus 3D, this is your AP, and you have a GP, and your GP is like 1 R square R cube. This is like your GP. Now if you multiply these terms, then you will get AGP. So how do you get AGP? You will get AGP if you multiply these terms. So that will be your AGP will be like this: A, then it will be A plus D into R, then it will be A plus 2D into R square, then it will be A plus 3D into R cube. So like this you will get AGP. So what is AGP series? You have AP series, you have GP series. The multiplication of AP series and GP series, you can notice the multiplication of AP series and GP series, that is your AGP series. Okay, now I told you that infinite AGP series is very important. This infinite AGP, this series is extremely important for generative function, important for generating function. So for this infinite AGP, we have a formula I told you. Okay, so if you solve this infinite AGP, but here you have to take care. When you remember that formula, you have to take care. Okay, for example, if I tell you that this is your, remember, if your AP is like this, again, A plus D, A plus 2D, your AP should be like this. This is your AP. Your GP should be like this. If you want to apply that formula directly, your AP should be like this: A plus D, A plus 2D, and so on. Your GP should be like this, starting from 1 R square. This should be your GP. In this situation, you will get AGP, and that AGP you will get like this: A plus DR plus A plus 2D R square plus, and so on. So for this infinite AGP, now this is your infinite AGP. For this, the formula you have, and that is A upon 1 minus R plus dr divided by 1 minus R whole square. Okay, this is the formula. But remember, if you directly want to apply this formula, if you want to directly apply, then your AP should be like this: A plus D, A plus 2D, like this, and your GP should be like this: 1 RR. Okay, so this is important. If you want to directly apply the formula, then your GP should be starting from 1. Your GP should start from 1 RR square, and your AP should be like this: A plus D, A plus 2D. In this situation, you can directly apply the formula for infinite GP. This is very important. This should be infinite. This should not be finite. This should be infinite. This formula is for infinite GP, for infinite AGP. For infinite AGP, you have this formula. Okay, very simple. Now let's solve questions using questions. With questions, I will tell you what I mean. Okay, let's solve this. So remember, when applying infinite AGP formula, take care. What you have to take care? What you have to take care? That your AP should be A plus D, A plus 2D. Your AP should be like this. And remember, your GP should start from 1 R square. Your GP should be like this. Okay, individually your AP should be like this, your GP should be like this, and their multiplication should be your AGP. Your AGP should be their multiplication, like A, and then this A plus DR. Okay, and then A plus 2D R square. Your AGP should be like this. In this situation, for this infinite AGP, you can apply the formula. Now let's solve this question. Tell me, for this question, can you apply that formula? That formula can you apply for this question? Why not? Please tell me why not? Why we cannot apply that formula for this? Because this is not infinite. Very good. This is not infinite. The reason is this is not infinite. The main reason is this is not infinite. Please note that it is not infinite AGP. This is not infinite AGP. So for this finite AGP, always what we have to do? Remember, if you have a finite AGP, then what we have to do? Always don't by heart the formula. Always apply the procedure. always apply the procedure. If you have a finite AGP, then always apply the procedure. Always apply the procedure. Okay, and if you have infinite AGP, then for infinite AGP you can apply formula, but take care, you can apply the formula, okay, with care, with care. Now let's see, so how to solve this? Just apply the procedure. Okay, let's apply the procedure. So this is your S is equal to, let's assume that the summation is S is equal to 1. Okay, this is your S, this is the summation, and so on, 100 multiplied by 2 power 200. Then what is the procedure? Can anyone tell me? See, we have already taught this procedure we have already taught. So what we should do? Multiply with the common ratio of GP. This is your GP, this is your GP going, this is the GP going. So you multiply with the common ratio of GP. You multiply with the common ratio of GP, then you shift. Okay, you shift it. Okay, so you write all the terms by shifting it. So multiply with 2. If you multiply this with 2, this we multiply with 2, we got 2s. If we multiply this with 2, then we will get this. If we multiply this with 2, we will get 2 into 2 cube, and so on. You shift it, and then the previous term that will come here when you multiply by 2, and then finally this will be 100 into 2 power 101. That will be 100 into 2 power 101, because we are shifting. I am multiplying this with 2, multiply and shift, multiply and shift, multiply and shift. Similarly, multiply and shift. Okay, is this clear to everyone? Now you subtract. So S minus 2S, what that will be? That will be 1 into 2 plus 1 into 2 square plus 1 into 2 cube plus, and so on. What that will be? 1 into 2 power 100 plus 100 into 2 power 101. So now can you notice this? Just notice this one, this much, only this much. What is this? This is your GP. Now you got your GP. Okay, you are subtracting, sorry, you are subtracting, so this will be minus. So this will be minus, because we are subtracting. See, we are subtracting, right? S minus 2S, we are removing from this we are subtracting the second one. So this will be minus, this will be minus. Okay, now what you will get? So you will get minus S is equal to, can anyone tell me what is that? And minus, that will be 100 into 2 power 101. So what that will be? 1 into 2, 1 into, so basically 2 square, 2 cube, 2 power 100. How many terms we have? This is your GP. This is your GP. How many number of terms? Tell me the number of terms. That is 100. There are 100 terms. We only have 100 terms. So we will have this first term. First term is 2. First term multiplied by common ratio is 2. 2 power 100 minus 1 divided by 2 minus 1. So finally S will be what? S will be equal to 100 into 2 power 101 minus 2 into 2 power 100 minus 1. Okay, so this will be your answer. Is this clear to everyone? Tell me. So this is your answer, or you can if you want, you can solve it like this. Then this will be 2 power 101 plus 2. Okay, so finally it will be from 100 into 1, so that will be 99 into 2 power 101 plus 2. This will be your final answer. Yes or no? Is this clear to everyone? So remember, this is a finite GP. Whenever you have finite AGP, just apply the procedure. You know the procedure. Multiply with the common ratio. This is the GP. This is the GP. So the common ratio of GP is 2. So multiply with 2. This is the step. Multiply with 2 and shift and shift. Multiply with 2 and shift. Then what you do? Then you subtract. From this first one, you subtract this second one. Then you will get S minus 2S is equal to this. This is GP now. And this GP formula you already know. Okay, so finally the answer will be, the final summation will be this. This will be your final answer. Yes or no? Let's see this. What is the answer? So let's take this as a homework. Okay, please take this as a homework. You can discuss this in the group. This is your finite AGP. Very simple. This is your finite AGP. So what you will do, if this is your finite AGP, what you will do? Can anyone tell me? Then you will apply the procedure. Always apply the procedure when you have finite AGP. Apply the process. Very simple. Okay, so just check. These are the four options. Which option is correct? You check it out. Now let's see this question. This is your infinite AGP. Yes or no? Finally, now we have infinite AGP. But tell me, for this infinite AGP, can we directly apply the formula? For this infinite AGP, can we directly apply that formula? Like, for example, can I directly apply that formula? No, because see, why I cannot apply that formula? See, notice. Can anyone tell me this is your AGP? Can anyone tell me what is AP here? Okay, please notice what I'm going to do. Very important. Can anyone tell me what is AP here? What is just give me the AP? The AP is 1, 2, 3, 4. This is the AP. And can anyone tell me what is GP here? The GP here is 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on. Tell me, okay, what is R? Can anyone tell me what is R? R is equal to 1 by 2. Is it starting from this GP? Is it starting from 1? Is this starting from 1? No. So can you directly apply the formula? Can you directly apply the formula? No. So cannot directly apply the formula. Cannot directly apply formula. You cannot directly apply formula. So don't directly apply formula. Now let me tell you two ways. Two ways I can tell you. Two very nice ways. If you want to convert this into our desired expression, so directly you cannot apply the formula. Now there are method. There are two methods. Method 1. What is method 1? Can anyone suggest what is method 1? The method 1 is just take 1 by 2 common. This 1 by 2 you take common. This is your series. 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16. This is your series, right? This is your series. Then what you do? Just take 1 by 2 out. Just take 1 by 2 out. Can I take 1 by 2 out? Then what I will get? I will get 1 plus I will get 1 by 2 out. So I will get this 3 upon 4 plus 4 upon 8. So because I am taking 1 by 2 out. Now, did we get our desired expression? Now tell me. Now for this, can we apply the direct formula? Can we apply the direct formula here? Now, yes, you can apply the direct formula. Now you can apply the direct formula because what is AP here? Please tell me AP. AP is 1, 2, 3, 4. This is your AP. And what is your GP here? Your GP is 1 upon 1 by 2, 1 by 4, 1 by 8. This is your GP. This is perfect, right? This is perfect to apply the direct formula. Yes or no? This is what we want to apply the direct formula. This is your AP. 1, 2, 3, 4, and so on. This is your GP starting from 1. Okay, and now you can apply the direct formula. So direct formula you can apply. Isn't it simple? Like what we did, we are taking 1 by 2 out. From this, we are taking 1 by 2 out. So you take 1 by 2, you take 1 by 2 common, 1 by 2 common. Then finally, now you can apply the direct formula here. So what I will get? So this S, that will be equal to 1 by 2. Now you apply the direct formula. So that will be A. What is A here? A means this is your A. This is your A. So finally I can say A upon 1 minus R. 1 minus R. This is okay. Plus dr. What is d? The difference. What is d? D is 1. The difference is 1. So that will be d into r. R is 1 by 2 divided by 1 upon 1 minus 2 whole square. So finally S will be what? 1 by 2. And what this will be? Half. So that will be 2 plus, again I think this also will be 2. So finally it will be, answer will be 2. So your final answer will be 2. This is your method 1. Can anyone suggest another method? Did you understand this method? Did you understand? See, we cannot directly apply the formula. You cannot directly apply the formula. So what we are doing, we are taking 1 by 2 out. This 1 by 2, we are taking it out. Now once you take it out, now you can apply the direct formula because now your GP is starting from 1. Now your GP is very nice, starting from 1. Okay, so very simple. Now tell me, what is the method 2? Now let's see the method number 2. So let me tell you, the method number 2 is like this. Very simple. See, this method 2 is actually much better than method 1. This is much simpler than method number 1. Your question is 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16 plus 5 by 32 and so on. This is your question. Now, I told you that in this question, your AP is like this. 1, 2, 3, 4. This is your AP. In this question, your GP is like this. 1 by 2, 1 by 4, 1 by 8, 1 by 16 and so on. Now, so we don't have the desired format because this is starting from half. This is starting from half. So this is not desired. So what I am going to do to get the desired format? See, if I put 0, will AP disturb? If I put 0, will AP disturb this AP? Will it disturb? Will this AP disturb? No, this will not disturb. Okay, this AP will not disturb because still the difference is 1. The common difference is 1. The common difference is 1. So AP will not disturb. The common difference is a 1. AP will not disturb. And if I put 1 here, will GP disturb? Will GP disturb? Will GP disturb? GP will not disturb because you can notice okay, still you have half. So your GP also will not disturb. And will your AGP disturb? Will your AGP disturb? So your AGP will be 0 plus your AGP will be, this will be 0, this will be 1 by 2, this will be 2 by 4, this will be 3 by 8. So will your AGP disturb? Your AGP is also not disturbing, right? Yes or no? So if this is your, if this is S, if this series is S, then this series is also S, and we are just adding 0. Yes or no? Are you getting? Are you getting this? Because we are getting our desired format. This is our desired format. Our desired format we are getting. And what we are doing, very simple. We are just putting the 0 in the AP. In the AP, we are putting 0. In the GP, we are putting 1. The AGP will not disturb because 0 multiplied by 1, that will be 0. 1 multiplied by 1 by 2, that will be 1 by 2. 2 multiplied by 2 by 4. 3 multiplied by 1 by 8. 4 multiplied by 1 by 16. So this will be S. So now tell me, now this is your series. Very simple. Isn't it easy? This method is actually much better. Now you can apply the direct formula. Now for this AGP, you can apply direct formula. But tell me, if you apply direct formula, what will be your A? What will be your A? A will be 0. A will be 0. A will be 0. And what is difference? Difference is 1. And what is common ratio? Common ratio is half. So now you apply the direct formula. So if you apply direct formula, that will be A upon 1 minus half. This will be 0. This will become directly 0. Next, plus D into R divided by 1 minus R whole square. Okay. So if you solve it, answer you will get 2. Is this clear? So note this, please note this, that if you want to directly apply the formula for infinite AGP, if you have an infinite AGP, and for this infinite AGP, if you apply this formula, infinite AGP summation, so this note you take, please understand this. So if you want to apply this formula, A plus A upon 1 minus R plus dr upon 1 minus R square, if you want to directly apply this formula, then to apply this formula, your AP should be A plus D, A plus 2D. Your AP should be like this. And your GP should be 1 R, R square and so on. So your GP should start from 1. Nothing else is the restriction. And in this AP, this is your A. Okay, your GP should start from 1. Your AP is A plus D, A plus 2D. This is your AP and your GP should start from 1. So this is the idea. This is the infinite JP formula. This formula you can just apply, but you have to take care. So method 1, method 2. Did you understand method 2? What we are doing? We are just putting 0. This 0 we are putting extra, nothing else. Because of this 0, this A will become 0. And because of this whole thing will become 0. So method 1, method 2. Which method, like, did you get both the method? Method 1, method 2. Two methods we have seen. You can apply whatever method you want. You can apply. Okay, that is your choice. I have told you both of the methods. Can I give this question as a homework? This is another question, similar question, very similar question. So please take this as a homework. Okay, and the answer is also here, so you don't have to worry about it. Answer I have provided. Now let's solve this question quickly. Find a plus b. The question is saying that the infinite summation s can be written as a by b, where a comma b are co-prime positive integers. A comma, so okay, basically this s can be written as a by b, where a comma b they must be co-prime positive integer. Then find a plus b. So what will be the answer? The answer will be 91. Very good. Okay, so you can solve this question. I am not going to solve this completely, but the question is very simple. The question is saying that s is equal to 0.1. Okay, this in this question, s, this is your 1 by 10, right? I can write it 1 by 10. Then I can write it 2 by 10 square. Then I can write it 3 by 10 cube. Then I can write it 4 by, okay, and so on. So this is the infinite AGP. This is your infinite AGP. Okay, tell me, this is in the desired format? Is this in the desired format? Is this in the desired format? This is this infinite AGP. This is not in desired format, right? This is not in desired format. Why this is not in desired format? Because for this you can notice that your GP is starting from 1 by 10. Your GP is starting like this. Your GP is starting. There is no problem with AP. There is no problem with AP, but your GP is starting from 1 by 10. So this is not a desired format. This is not in desired format. So what we can do to convert this into desired format? What is method number 1? What is method number 1? You can take this 1 by 10 out. You can take this 1 by 10 common, and then you will get this. You will get, just take 1 by 10 common, then you will get this. Now you have a desired format. Now this is in the desired format. You can clearly see. Okay, now this is in the desired. This is in the desired format. And because you have this in the desired format, you can apply the formula A upon 1 minus R plus dr upon 1 minus R whole square. And this is your A. This is your A. Okay, and what is D? What is D? D is 1. D is the common difference of AP. Okay, so this is the idea. Very simple. So S will be equal to 1 by 10 multiplied by this formula. So this is your method number 1. Understood? So take 1 by 10 common. Just take 1 by 10 common, and then you will get a desired format. Just take 1 by 10 common. Now, what is another method? What is method number 2? That is much easier. Method number 2, just add 0. If you add 0, then see something will happen. See, if you add 0, basically I am adding 0 into 1. This is what I am doing. 0 into 1 I am adding. Okay, I am adding 0 into 1. Now you can notice this is very simple. So finally, now this is in the desired format. This is in desired format. Why this is in the desired format? Because your AP is 0, 1, 2, and so on. This is your AP, and your GP will be 1 upon 1 by 10 upon 1 by 10 square, and so on. So your GP is also in the desired format. AP is also in the desired format. So finally, for this answer will be, okay, that will be D is 1. Okay, so that will be D into R upon 1 minus R square. So what will be S? S will be equal to upon 10, okay, 100, I think 99, right? Sorry, 81. So that will be 81. So the answer will be 10 divided by 81. Are they co-prime? The question is asking, are they co-prime? The question is asking, are they co-prime? So tell me, are they co-prime? 10, 81. Yes, these are co-prime. Yes, these are co-prime. These are co-prime. So finally, I can say that because these are co-prime, so your A plus B equal to 91. Okay, this question you can take as homework. This is a simple question. Calculate the value of this summation. Okay, and you can just check it. The answer is here. Solution 1, solution 2. The answer I am providing in the slide. This question also I am giving you as a homework. This is asking the value of P. so that this infinite AGP summation is 8. This is an infinite AGP and the summation is 8. So the question is, what is the value of P? Okay, can you do this? Very simple. Is this in the desired format? You tell me. Is this already in the desired format? Already, is this in the desired format? If this is in the desired format, then tell me. You can directly tell me the answer. This is already in the desired format. This is already in the desired format. Because what is your AP? Can anyone tell me what is your AP? AP is 3 plus P, 3 plus 2P. This is your AP. And what is your GP? GP is 1 divided 1 by 4, 1 by 4 square. This is your GP. So this is everything is in the desired format. So you can apply the formula, direct formula you can apply. That will be A. This will be the value A. A divided by 1 minus R. R is 1 by 4 plus D. What is D? What is the value of D? D is equal to P. This is your D. So finally that will be dr divided by 1 upon 1 by the 4 whole square. So okay, and you just what you do, you put this equal to 8. So finally you can calculate the value of P. Yes or no? So this is a very simple question. Already this is in the desired format. You can take this as a homework. Just find the value of P and these are the options. Similarly, this question you can take as homework. Again, the same thing, A by B, you have to represent in A by B format, and then you have to find what is A minus B. This is your AGP. So all these questions you try. Now, let's see this question. So can you try all the questions that I have given as a homework? We have already seen 3 or 4 questions from AGP. Those are enough. Now let's see. So this is your sequence. A sequence is given to you 0, 1, 2, 3, 4. So what is the generative function for this sequence? So very simple. The generative function for this sequence, that will be, remember, this is your A0. This is your A1. So finally that will be x plus 2x square plus 3x cube plus 4x power 4 and so on. Is this desired? Is this in the desired format? This is the open form. This is the open form of generative function. So this is your generative function, but this is the open form. We want the closed form. This is not in the desired format. This AGP, this is your AGP. Yes, this is AGP. This is AGP. But formula cannot apply directly. But formula is not applicable directly. Is not applicable directly. So you cannot apply the formula directly. Remember, this is AGP. Yes, this is AGP, no problem. But you cannot apply the formula directly. So what you need to do for this? So your gx is equal to x plus 2x plus 3x square. So this is not in the desired format because your GP, if you notice, your GP is x 2x square, 3x cube, and so on. Okay, so your GP is like this. Your GP is starting from x, and your AP. Can anyone tell me what is your AP? Can anyone tell me what is your AP? Your AP is 1, 2, 3, and so on. So very simple method you can apply. Just put 0. Just put 0. If I put 0 here, will AP disturb? Will this AP disturb? The AP will not disturb. If I put 1 here, nothing will disturb. Okay, if I do this, nothing will disturb. So finally, my gx will be equal to, that will be d into r. So that will be d is 1. Okay, r is x, d into r upon 1 minus x whole square. So this will be the answer. Or you can take x out. Or the method 2. What is method 2? You can take x common. Method 2 is x common. Just take x common. If you take x common, then inside what you will get? Inside you will get 1 plus 2x plus 3x square and so on. Now this is your AGP. Now this is your desired format of AGP. Desired form of AGP. But this method is better, right? Yes or no? This 0, like this putting, because if you put 0, then nothing will disturb. and if you put 1 here, nothing will disturb. Nothing will disturb. This is x, 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 and this is 1, 1, 1. Okay, so this method is actually nice. Very simply you can do. But you have two methods, method 1, method 2. Whichever method you want, you can apply. Now let's solve this question. So tell me, what will be the answer? M is a positive integer. The question is saying that M is a positive integer. M is a positive integer. AK is given to you. AK is C M comma K, where K is 0 to M. What is the generative function for this sequence A0 to AM? What is the generative function for this sequence? So first of all, what is your sequence? You tell me what is your sequence. M is already given. M is a positive integer. Some positive integer is given to you. The question is asking what is the generative function for this sequence. What is your sequence? You just find. M is a positive integer. Your sequence is K is going from 0 to M. So your sequence is MC0, MC1, MC2, and so on. K is going till M. This is your sequence. Yes or no? So what will be the generative function for this sequence? Remember, this is your A0. This is your A1. So you can apply the generative function. Definition, just apply the definition of generative function. So that will be M1x, MC2 x square, and so on, MCM x power M, x power M. So what is this? What will be the answer? Have you seen this? This is your combination. Choose. This is the combination. So you have seen this, right? Yes or no? This is binomial theorem. You have seen this in the binomial theorem. What is x plus 1 plus x power n? What is that? That binomial theorem, nc0 plus nc1x plus nc2x square, and so on, ncn x power n. This you have already seen. So from 0, you can notice mc0 to mcm x power m. So that will be 1 plus x power m. This will be the generative function. Is this clear? So this type of question they can ask. This sequence they can give, and for this sequence the generating function is 1 plus x power m. 1 plus x power 4. What is that? That is 4c0 into x power 0. X power 0 is 1. X power 0 is 1. So I can say 4c1 x plus 4c2 x square plus 4c3 x cube plus 4c4 x power 4. Yes or no? So this is the binomial theorem. We have seen this. 1 plus x power n, like 1 plus x power 4. Then we go from 4c0 to 4c4. And x square x power 4. Finally x power 4. So you are starting from, you are starting from 0 and you are going till n. So, okay, and you can notice x square x power n. So this is your binomial theorem. So using the binomial theorem, the same thing is happening here. You are going from MC0 till MCM. So if you find the generating function, the generative function will be x, just multiply by, just apply the definition of generative function and you will get 1 plus x power m. Tell me one more thing. Let me ask you one more question. If I remove this, okay, like if I remove this, and if I just ask you this, like if I remove this, and if I just ask you this, means it can go on. Now, will the answer change? Will the answer change? Basically, now I am changing the question. Now my question is like this. MC0, now this is the sequence. MC1, MC0, MC1, MC2. There's somewhere MCM will come, then MCM minus M plus 1 will come, then MCM plus 2 will come, and so on. So this is infinite sequence I am giving you. Will the answer change? The answer will not change. What is the reason? What is the reason answer will not change? Because all these things will become 0. All these things will become 0. Remember, M is a positive integer. So you already know that when M is a positive integer, then you know MCM plus 1, that will be 0. Okay, similarly, MCR that equal to 0 when r is greater than n, when r is greater than n. So all these terms will automatically become 0. All these terms, they will automatically become 0. So ultimately you have only this, and all the remaining terms will be 0. All the remaining terms will be 0. So what will be the generative function? That will be same, 1 plus x power m. The same answer. Answer will not change. Answer will be the same. Because you know, the remaining terms will be all the zeros. So I can also write it k c k plus 1. I can also write it k c k plus 2 and so on. But here assume that k belongs to set of natural number. This is what you assume, that k is a set of, means positive integer. K must be positive integer. So all these points, are they clear? Like for example, for this sequence, the generative function, what it will be? For this sequence 1 1 1, for this sequence the generative function will be just append all the zeros. This will be your generative function, and you will apply the GP formula. This is a GP. You can notice this is a GP. This is a GP. Number of terms is 3. Okay, so this is GP. And similarly, you can find what is the generative function for this sequence. For this sequence, generative function will be like this.